Hi, thanks for joining me. Today I'm going to be talking about inequalities and one in particular that seems to not follow the pattern. I've written down what we know so far, and that is that n to the a is less than b to the n is less than n factorial is less than n to the n, and this inequality is sort of true. And what do I mean by sort of true? Well, it kind of depends on a, b and n, but essentially if we look at this kind of first inequality here, if you give me some positive integer a and some positive integer b, which is at least 2, then I know that for sufficiently large n to the a is going to be less than b to the n. This is a common fact. I'm not going to prove it in this video. Let's look at this next inequality here. B to the n is less than n factorial. Again, if you give me some positive integer b, then there's sufficiently large n such that b to the n is going to be less than n factorial. And this last inequality here doesn't have any a's and b's in it, but n factorial is less than n to the n. Well, that's also true for sufficiently large n. So these inequalities are certainly true, and if you've not seen them before, perhaps go and look them up or try and prove them yourself. They're not too difficult to prove. But what we're going to be doing is noticing that if we take any of these first two inequalities and we square the term on the left-hand side, the inequality sign stays the same. So what do I mean by that? So we've got n to the a is less than b to the n, but we might ask ourselves, well, what if we square this left-hand side? Does the left-hand side, can we still have that less than sign there? And the answer is yes, because n to the a all squared, if we just get rid of the brackets and bring the 2 down, this is just n to the 2a, like so. But of course, if a is a positive integer, then 2a is a positive integer, and I can just call it a tilde, and I get this guy here. But of course, this guy here is just essentially the same thing as what we have here, except a replaced with a tilde, so using the fact that this is true for some, sufficiently large n, then we also get this inequality here. So if we square this term on the left-hand side, we're still going to get this inequality here, but it might require a bigger n, but that's fine. How about we look at this inequality here, b to the n is less than n factorial. And if we square this left-hand side here, we get b to the n all squared, but of course this is just the same as b to the 2n, but b to the 2n is just b squared raised to the n, but b squared is just some other positive integer, which I can call b tilde. So we get b tilde raised to the n, and of course we know that that is less than n factorial for sufficiently large n by that guy there, just replacing b with b tilde. So we have those two inequalities still hold when we square the term on the left hand side, but we're going to be asking ourselves, well, does that hold for this guy here? Because now we don't have any a's or b's, we just have n factorial being less than n to the n. So we want to ask ourselves, is for sufficiently large n, does n factorial, when you square it, is that guy less than n to the n? Okay, so if you want to have a go at trying to work out whether this inequality is true or not, pause the video now and give it a go for yourself, and I'm going to get stuck straight into a solution. Okay, so we want to know, is n factorial squared eventually less than n to the n? And the answer to this is actually no, and in fact this inequality sign should be the other way round. I claim that for sufficiently large n factorial squared is in fact bigger than n to the n. Well, before we get into the proof of that, let's just do some exploration on some small cases of n. When n equals 1, we have the left hand side is 1 factorial squared, and that's just 1, and the right hand side is 1 to the 1, so that's 1, so we have equality. When n equals 2, we have 2 factorial squared and 2 to the 2. The 2 factorial squared is 2 squared, which is 4, and the right hand side is 2 to the 2, which is 2 squared, which is also 4, so we have equality. But as soon as we hit n equals 3, we have 3 factorial squared, which is 6 squared, which is 36, and the right hand side is 3 to the 3, so 3 cubed, which is 27. And of course 36 is bigger than 27, so we see this inequality is true for n equals 3. And the way to see that it's true for all the other n's as well, that all n's bigger than or equal to 3, well, let's just look at this left hand side here. We've got n factorial squared. Let's just use the definition of n factorial. So the left hand side, n factorial squared, well, that is just n times n minus 1 times so on all the way up to 3 times 2 times 1, and then of course we're squaring that, but squaring that is just multiplying it by itself. So what I'm going to do is just multiply it by itself, but this time I'm going to write the order in the other way around, and perhaps you can see where I'm going with this. So I'm going to times it by 1 times 2 times 3 times so on all the way up to n minus 1 times n minus, oh, it's just times n, sorry, like so. So this guy times this guy, and then what I'm going to do is pair up terms. So I'm going to pair up this n and this 1, this n minus 1 and this 2, this n minus 2 here and the 3, and so on. So I'm going to get, this is equal to n times 1 times n minus 1 times 2 times so on, all the way down to, I'll pair this 2 with this n minus 1, so get 2 times n minus 1, and this one with this n, so 1 times n like so. But we notice, if we just have a look at this, well, this guy here is certainly equal to n. This guy here though, for sufficiently large n, this guy here is going to be bigger than n, quite clearly, because n minus 1 times 2 is just going to be 2n minus 2, and provided that 2n minus 2, well, 2n minus 2 is almost double n, so certainly it's going to be bigger than n. Similarly, the next term is going to be n minus 2 times 3, and of course that's going to be bigger than n for sufficiently large n, and so on. So all of these terms here are going to be bigger than n. Well, how many terms do we have here? Well, we have n of them, so this guy here is going to be bigger than n multiplied by itself n times, so n to the n, like so. And that's why we get this inequality here. Now, the reason we get equality in the case n equals 1 and n equals 2 is just because there are too few terms here. So, for example, when n equals 1, we don't have any of these terms, and we just have 1 times 1, like so, and this 1 times 1 here, and of course that's just going to be 1. So these guys here clearly just equal n. And when we have n equals 2, notice that these terms here aren't going to be bigger than n, they're just going to be exactly equal to n. Because then when n is 2, we've got 2 minus 1, which is 1, and 2 minus 1 there, which is 1, so the 2's, those there are just both equal to n. But then for any n bigger than that, all these guys here are going to be strictly bigger than n to the n, and hence we get this guy here is bigger than n to the n, and that's for n being bigger than or equal to 3. And what's really interesting about this result is if we go back to the start, the introduction of this video, when I had, what did I have? N to the a is less than b to the n is less than n factorial is less than n to the n, is I showed that if you square any of those inequalities on the left hand side, if you square any of the terms on the left hand side, the inequality is going to hold the same. But I've just shown that in this case, so in that last inequality, n factorial squared, so n factorial and n to the n, when you square n factorial, the inequality is actually going to change sign, which I think is pretty cool. Anyway, I hope you have enjoyed this video, and I hope you've managed to follow along. Thank you for watching. I'll catch you in the next one. Have a great day.